Hello and welcome once again to Physicsify. Today we are starting off a very new chapter and I hope you know this is the first chapter that we face in physics class 11th. This happens to be vectors, right? So today we are going to have the part 1 in vectors in which we would like to deal with some of the basic things like we'll talk about a physical quantity and we'll talk about what are scalars and vectors. So let us proceed. What exactly do we have first? We are being asked, what's a physical quantity? What exactly do you mean when you say that you have a physical quantity? You say that anything that we can measure, anything that is worth measuring, anything that can be measured in something, we call this as a physical quantity. So if it is not measurable, then we will not call it a physical quantity. As simple as that. So there's a lot of things that you have studied till now, from your basic starting class 6th. Maybe you started off with science or maybe you started off with physics. You have seen a lot of units, a lot of things. Let's try to see what all things you have seen. You have seen area, right? You have seen mass, you have seen volume, right? Guess what? If you remember, density is mass per unit volume. We can calculate that as well. If we talk about the next things, distance, we talk about displacement. These are some things that we say are lengths. And if we talk about more, let's say we talk about temperature. All these things could be measured. If you start to write down, I think you can say area comes in meter square, mass comes in kg, volume comes in meter cube, density comes in kg per meter cube, distance comes in meters, displacement comes in meters, length can also be said to be in meters, temperature comes in maybe degree Celsius, maybe degree Fahrenheit, maybe Kelvin. So the next thing we say is that all these things are good to go with respect to our physical quantities. But what are the things that are not physical quantities? Let us say I ask you that India wins the World Cup. How happy are you? You cannot tell that I am this happy, this happy. I am 20 kg happy. I am 50 degrees Celsius happy. No. Happiness does not have a unit. Happiness cannot be measured. It can just be said that I am either happy or sad. Right? Similarly, if I talk about pain, let us say that you broke your leg. Somehow you fell, you broke your leg. I ask you how much pain you are having. You say 20, 550 pain I am having, 100 pain. I am having 1000 pain. No, you cannot define it with respect to something that can be measured. Similarly, if I ask you how much does your mother love you? Right? How much do your parents love you? Can you tell me they love me 5, 10, 20? No. There's nothing to measure that in. So we say that these three quantities probably does not qualify under physical quantities. Alright, let's move ahead. Let's try to talk about what's the need of vectors. Why exactly do we require vectors? So what I am saying is that if you talk about any physical quantity, we saw a lot of physical quantities, they are having two things at least. What are these two things? They can be defined with a magnitude and they need a unit. Now, people ask me, sir, what do you mean by magnitude? Right? I say magnitude is just a number, it's a numerical value. And unit is something that you measure it in because physical quantities are things that can be measured. Right? So, what we say is that physical quantity, if you want to write, it is a magnitude, it's a unit. Magnitude, this thing being the numerical value that is present over here and a unit as well. Now let me explain to you with an example, you'll understand that much better. So if I say that there is 2 kg tomatoes, what can you say? You can say that over here the physical quantity being talked about is mass and it is being said that 2 kg, 2 is the number, it is the magnitude, it is the numerical value while kg is the unit, right? Similarly, if I talk about somebody getting COVID positive, God forbid, but if I hope it does not happen to anyone. But if that happens, you fall sick, you get a fever, right? If you're getting a fever, you can measure the temperature. Let us say it is 101. What is it 101? Degree Fahrenheit. So 101 is the magnitude while F happens to be the unit. The next thing if I talk about, let's say that I wanted to visit Taj Mahal, right? and I wanted to go to Taj Mahal, and I was going from Delhi. So I know that if I have to move from Delhi to Agra to visit Taj Mahal, I have to cover some distance. My physical quantity is distance, whose numerical value, whose magnitude is 242, 242, and the unit is kilometers. Right. I hope you are able to understand what's the need of vectors a little bit, maybe, or maybe a little bit not. But yes, if I would like to define to you that why and where are these vectors coming, you should also know a second thing called scalars. Right. So this is the most important thing of this first class of ours, that you understand the difference between scalars and vectors. You understood physical quantity, that is about it, that it needs some magnitude, it needs some unit, but vectors are something special. They require something extra. So let me tell you what scalar and vector are and what is the major point of differentiation. First thing that we say is that if you talk about any scalar quantity, you have a numerical value and you have a unit, right? You just saw mass, you just saw temperature, you just saw distance, right? But if you talk about a vector, I'll tell you, these things are required. Numerical value and unit, magnitude and unit is required, but you also require a second thing called direction. Now what happens is that a lot of people say that if I have a magnitude and a direction, I call it a vector. They are very happy with saying that. But let me tell you, that's not enough. That is the necessary condition, but it's not sufficient. What is the sufficient condition? What is this one thing that we are lagging, that if we get this, we can 100% say this is a vector? That happens to be your vector law of addition, right? This is the necessary and the sufficient condition, that if your things are having a magnitude, a numerical value, a unit, and a direction, and they also follow this rule, then only will you say it is a vector. Otherwise, if they follow scalar addition, what is scalar addition? Normal rules of algebra. If they are following those normal rules, you will call that as scalar. But if they follow some certain special set of rules, you call them vectors. So let me elaborate this second point, this second and third over here. These are most important. Now, if I say I wanted to add 2 kg and 3 kg, you add it anyhow. Anyhow you add, you will always get 5 kg. Always. Never will it happen that 2 kg and 3 kg add up to 10 kg or 6 kg or 1 kg. They will always and always add up to 5 kg. So that is why you are saying this is the scalar addition. This plus sign that I say, this is the scalar addition. Right? ADDN is addition. But if I talk about vectors, you'll see how they are different. Now comes the major point. If I want to add 4 meters and 3 meters, it can be done in a lot of ways. How? I'll show you. See, if I talk about the first thing, that 4 meter and 3 meter, both of them are in the same direction. I say you move 4 meter in this direction, then 3 meters again in this direction. You will say that, sir, I've moved 7 meters. I will say, very good. It appears that as if this is scalar addition, because 4 plus 3 gives you 7, and you will say that this time this plus seems to be that scalar addition plus. But if I ask you to move 4 meter towards right and then 3 meter towards left, what will happen? This time your 4 meter, this is said 4 meter plus 3 meters, because this is vector addition. So vector addition can give you something as 1 meter. How? Because you are moving 4 in one direction, 3 in other. So you are effectively cancelling out 3 meters that you move towards right, and you are left with a net of 1 meter towards right. This is vector addition. That 4 meter plus 3 meter could give you 7 meter. It can even give you 1 meter. And guess what? You know Pythagoras theorem. If you move 4 meter towards the right and 3 meters towards up, I think you know that this is 90 degree. And in this case, your final answer would be 5 meter. So 4 meter plus 3 meter giving so many answers. Why? Because this time we are talking these things to be vectors. right? And vectors follow that vector law of addition. Vector law of addition could be any ways in these three ways. So it might appear that vector can be added through as a scalar, but it can be added differently as well, and that is one thing you need to look out for. If let us say somebody asks me that how was these two things added, I will say these were displacements, because displacement is a vector quantity and it can be added in this way, right? Let's move on further, and if I want to give more examples, I'm just going to give out more examples for you, that if you want to say, you can say that mass, distance, speed, temperature, energy, all these things happen to be classified under scalars, while displacement, velocity, force, acceleration, they are a lot more, right, in both scalars and vectors. But if ever it comes for you to write it down as a point of differentiation, you can write this over there, right? Let's move on further, and now we have some tricky points, right? What are the tricky points? First thing, all vector quantities have direction, but all quantities that have directions are not vectors. What do you mean? It means that if something is having a direction, will you call it a vector? No. If somebody has a direction, you will not say that it is a vector. If it is a vector, can you say it has direction? Then it definitely has direction. Vectors automatically have direction. That is a given. But anything that possesses a direction might be having a direction but is not a vector, right? There are certain quantities that play out like that. So I'll talk about that in a little while. Don't worry. But let's take up the second thing over there. And the second thing says the vector condition is only one. I told you that earlier as well, that if you are obeying vector law of addition, that is the only condition we want to fulfill. Let's talk about the third point of R, and this is where I have related the first point, right? Now, what it says is that electric current and pressure, these are two such quantities that have both magnitude and direction. And you might be tending to say that this is a vector because you might have studied this earlier, that if you have magnitude, if you have direction, this is called a vector, right? But this does not follow our vector law of addition, and that is why they are not vectors. How? Let me prove it to you. It's very simple. You have done electricity in class 10th. You must be knowing this, that if I add 2 ampere and 4 ampere such that this angle is 60 degree, this gives you 6 ampere. In fact, this gives you 6 ampere irrespective of whether this is 60 degree or whether it is 30 degree. It will always be 6. If 2 and 4 come, they will always give you a 6 ampere current, right? I mean, this is not wrong. This is correct. This is also correct. And since it is not depending upon this angle, like whichever way you add, right? You can add 2 and 4 like this, and still it will give you 6 ampere. So the point over here is that if I, let us say, add 2 ampere and 4 ampere, something like this, this would again give me 6 ampere. So this does not follow vector law of addition, and that's why we will say electric current as well as pressure. These are two quantities. Please remember, they have a direction, but they are not vectors, right? This was the tricky point for us, and I hope you understood the basic parts, the physical quantity, the difference between scalars and vectors, and the tricky point, how things can have direction but still turn out not to be vectors. So this is ciao ciao from me. If you loved this class, please make sure you like and share this with your friends. And if you don't want to miss any update, do make sure that you subscribe now. Later.